Hello everyone, this is Mr. Denny. Today we're going to look at parametric modeling. So basically what parametric modeling is when you're creating a drawing in Inventor or any other CAD program, you can make it so that the dimensions aren't certain numbers. So you, instead of saying, oh, I want this rectangle to be 2 inches by 4 inches, you say, hey, I want this one side to be twice as long as the shorter side. And the reason you would do this is because you can come back and make different versions of it. For example, if you're making a pair of shoes, if you use parametric modeling when you're doing your dimensions, you can draw one shoe that's size 8 and then print out the dimensions and everything for it, and then go back and change one thing, and it would resize the shoe to a size 9 or 10 or 11 or whatever you need just by changing one dimension, and then you don't have to change all of your other dimensions. So it allows you to be more flexible. All right. So these are usually done on computers. Since the computer would do the calculations automatically, you can write parametric dimensions by hand and just write, oh, this side is twice as long as the other side. But it doesn't automatically calculate it for you, so it doesn't really give you the advantage there as much. So this adds another type of constraint to the ones that you've already learned. So you have geometric constraints. That's your things like make these parallel, make it horizontal, make these two curves tangent. Those are your geometric constraints. You have assembly constraints where you talk about, hey, let's make these two surfaces flush, or, insert this pin to this hole. Those are assembly constraints. And parametric constraints deal with making different objects a certain size relative to each other. So here are just some of the geometric constraints. Again, you see parallel and concentric and horizontal and things like that. And you'll remember this button from Inventor. You have about a dozen buttons here, and those are the geometric constraints. You probably did this in Unit 4. Parametric constraints, you specify more of an equation. For those of you that have ever used a spreadsheet like Excel or Google Sheets, you're going to be kind of familiar with the idea of using certain numbers in different cells to calculate a value. We're going to do the same thing here, but instead of using numbers from cells, we're going to use numbers from other dimensions. Now, sometimes you want the number not to change, and that's fine. You can just write like you normally would a dimension. For example, again, if we were making a shoe or something, and you always wanted the hole where the shoelaces go through to be 1/4 of an inch, you can just write 0.25. And then even though all the other sizes increase and decrease, that one will still say just 0.25. And that makes sense because the shoelaces don't change size. So some things you want to change, other things you don't. Sometimes they change in different speeds relative to each other, and we'll look at how that works some. All right. Now, if you want to get really advanced with this, you can actually set them up in a spreadsheet and then bring that into Inventor. And if we were in the classroom where we had all the computers there, we could look at how to do this. But for right now, we're just going to kind of keep it a little bit simpler. So every time you create a dimension, it's given a number. So the very first dimension you create is called D0. The next dimension you create is D1. The next one is D2, and so on. In this case, notice they're just using regular mathematical symbols: multiply, adding, subtracting, dividing, parentheses for orders of operation. And they're saying this dimension right here, dimension 7, is going to be whatever dimension 2 times dimension 0 is, divided by dimension 5, and then take the sum of that and add 2 inches to it. All right. So if you change dimension 2 or dimension 0 or dimension 5, you're going to change dimension 7. Here's another example of a place where you might want to do this. These are Adirondack chairs, traditionally used for sitting outside. And notice you can make them in children's sizes, you make them adult sizes. I actually have some chairs like this at my house. And I have chairs for my wife and I have chairs for my son who's a teenager, and my daughter who is in 3rd grade, and a daughter who's in kindergarten, and we have a newborn son. And so we've made chairs of all different sizes. And if I would create this in Inventor, I could make just one of them because they all have the same similarity. They all have the same pieces on the back. They still have the arms. It's all put together the same. It's just the dimensions change. Now, they don't always change exactly the same. For example, the thickness of the boards I make this out of, those are always going to be the same thickness. That's the way they come from the lumberyard. But how long the legs are changes, how wide the seat is changes, things like that all are parametric. They change relative to all the other sizes. Now, how do we actually go about doing this? Well, here's just an example plate, and you can see that it has a hole in it, it has a slot cut in it, and we have some dimensions here, both dimensions that locate where the hole is, like D10 and D11. We have dimensions that give overall sizes, like D0 and D1, and a size for the hole there, D12. And we have those for all of the basic geometric features. Now, if we wanted this plate to scale, we can look at these individual sides, and instead of just putting a number in for the dimension, we can say, I want this dimension to be based off of something else. So we can do this for lengths, and you notice it says right here, we can also do this with angles, do with all sorts of things. So here's the first little problem for us. They say they want the depth of the plate, D0, and the width of the plate, D1, to maintain a constant ratio. All right. So the way we'll do that is they say right now, D0 is 3 and D1 is 5. What equation could we put in here? Instead of just giving it a value, instead of just saying 5, what could we put in for a parametric equation that would always keep that ratio? Well, we know that 5 is 1.667 times bigger than 3. So if we always want this side to be 1.667 times bigger, instead of writing a number here, what we could do is we say, hey, we want dimension 1, the width of the plate, to be 1.667 times as much as the overall plate depth, which is dimension 0. So we could just say, okay, this equals 1.667 times D0. All right. And we could go ahead and you would just write that in. So when you came in here to do your dimensioning, instead of putting a number in the box, you would just write 1.667 times D0. Now, if you're like, how do I know which dimension is D0 or what dimension is which D what number? You can actually just click on the numbers and then it would work. So you see this is what it actually looks like in Inventor. You can go ahead and type it right in there. You could say D0 times 3/5, or you could say 3/5 times D0, or you could say 3/5 times and actually click over here and click on the dimension you want it to be. And that's the easiest way to do it. All right. We can also assign names to these. So instead of calling things D0 and D1, we can give them names. We can call them like width or thickness of plate or things like that. Usually we don't do this unless you're getting into something that's relatively complex and it's hard to keep track of it. Honestly, even then, usually what I do is I just take a piece of paper and I write D0 equals plate width, D1 equals plate length, just because it's easier to kind of keep track of it by hand than it is to go in and go through Inventor and do it all that way. But this is how you would do it. You go in and you just right click on it and go over to Dimension Display and you give it a name and you can rename it then. All right. And all of these, whether you rename them or you leave them as D0, D1, D2, they'll appear in your parametric units. And the way you can get them is you just click the Manage tab, and then they'll be right inside there. There's a little button for parametric units that you can click, and you'd see them. All right. And you can see all the useful information there. Now, if I wanted to actually go ahead and do this, just to show you what it looks like, I'm going to go ahead and create a new drawing. Let's go ahead and say I'm making just a pretty basic shape here. All right. And I'll say this is the dimension I'm going to base things off of. So let's go ahead. I'll say that's 2 inches. And I'll say I want this dimension to always be twice as much as that. So what I'm going to do is I'm going to just click on it, and notice it says it automatically puts the D0 in there. I'll say times 2, and it makes it 4. Now if I change this, if I wanted this to be 3 inches instead, notice now it automatically updates that to be 6. If I wanted to put a hole in, I could say I want the diameter of this hole to always be 1/2 inch more than 1/10 of that. So 3 inches divided by 10 is 0.3. We'll add 1/2 inch. So it's always 1/2 inch more. All right. And we could say that we want it to be, let's say we always want it to be 1 from the side. Notice if I put a number in here, I don't put any parametric modeling in, a couple of things are different. One, I don't see these letters FX before it. That means that this is calculated. So this number is calculated, that number is calculated. This number is always 1. And if I change this back to 2, everything else changes. This is calculated, so it recalculates, that recalculates, but this number was always 1, so it doesn't recalculate. All right, another way I can do this, one of the handy things to use it for is centering objects. So if I want this hole to always be centered, I can say, well, whatever this distance is, I want my hole to be back 1/2 of it. So if this is 2 inches, I want this to come down 1 inch, so I'll divide it by 2. This is 3 inches, it's 1.5 inches. So you can kind of see how that would work. All right, so that's that. We have a little bit of an exercise for you guys to work through, and that will pretty much do it.